Welcome, everyone. Today is April 15, and this is another of SIG Apps biweekly calls. My name is Mati, and I'll be your host today. Unfortunately, my screen sharing broke. There's a problem in 6.8 kernels. So I cannot share my screens, but I'll drop the link to the agenda. I don't have any particular announcement this week. Maybe aside from the fact that the 130 release is planned later this week on the 17th, and it's looking pretty good to be on the schedule. So with that, we can move over to Sergey and the serving workgroup topic. Take it away from here.
Okay, thank you. I started sharing my screen. I think you may see it now, right?
Yes, we can see it.
Okay, and it shows the agenda document, right?
Correct.
Okay. Um, I just came from vacation, so I may be a little bit slow. So please bear with me. Okay. So what we're doing here is we're proposing the new working group to be part of SIG Apps. This working group will be tightly related to other working groups that already are, particularly working group batch, and another working group that been proposed about accelerators and DRA. So this working group will concentrate specifically on serving workloads and AI serving workloads. So anything that will be um, serving and serving is not like batch serving, it's a serving on demand. So like people need to request uh, answer from this model, and then this will be a response will be generated based on that. And it's not like some work job that generates a bunch of answers for and process some queries in the background. So it's different type of serving. And we believe that a working group is needed for that because it's a very different set of people who may be interested in specific questions that certain workload raises. Um, like one of the first questions that we immediately see is multi-host serving when models doesn't fit into accelerators can be provided by single node, so we need to spread it to multiple nodes. And then you need to schedule it all together, you need to dismantle it all together. So you need to think about this model as a unit. So this and other scenarios is what we believe uh, driving the need for another working group. There is an email from week before, and this email outlines a little bit more details about like what specifically goals will be and what is a success for working group. I think like ultimately success is when many frameworks are doing serving will be using Kubernetes naturally, and it will be like good orchestrator choice for every framework that is doing serving of AI models. So this is an outline of proposal, and then there is a link to another document that is here. So this is document with specific use cases that we've been thinking about. As I said, that big use cases, multi-host serving, but there are also different scenarios. And I don't want to go to specifics of every single one of them. I would say that understanding how to serve, like, so AI presents unique problems. One of the unique problems is that hardware is expensive and it's hard to get. So any way to represent that I want to be scheduled on specific hardware and I want all this hardware together, or I don't want any, that is something that we want to do. And then for certain workloads specifically, since it's request based, so it cannot occupy whole node all the time, we need to be able to represent that I want a partial access to accelerator, or maybe like time partial, or maybe it's like split accelerator to multiple parts. This kind of representation is very important here. Plus, we thinking of like different types of workload. Like if you have a training and serving, sharing something that any type of preemption we can come up with will be very nice. Like people want to test some model serving, so you can schedule it really quickly, and it will preempt some other workload that is long running and they can wait, test it really quickly, and go on their way. This kind of scenarios are not supported today by Kubernetes really well, and being able to support them is also one of the goals of this working group. So yeah, you can read these use cases here, or you can ask questions. The goal of presentation here is first get initial feedback, like is there any particular topics we need to dig deep, or something that we shouldn't go about. And second is if SIGApp's is ready to sponsor it, maybe we can I mean, we're looking for more chairs. So like I volunteer to chair it, but if we can get more people participating and like helping drive this working group, will be great. With that, does anybody has any questions?
Yeah, go ahead, Clayton.
I was going to say too, I think, as both Sergey and I kind of talked to a number of the other SIGs or attended their meetings, I think there was kind of broad interest from folks in other SIGs. So it may be that we might get some of that interest in additional chairing from folks who would attend the working group meeting. But that leads into maybe one of the questions that I want to tee up for discussion here is, what's the role of SIG Apps, and how much of the SIG Apps time do we want to focus on working group serving versus do we want to keep it separate? Jan and I had chatted about that. Maciek and I had chatted about that. Just like, how do we effectively use the right channel and the right forum for discussing it?
Yeah, I mean, probably the workloads related topics, those will be touched over here, but the majority of them will span not only SIG apps, but also probably touching partially what the batch is working on. There will be probably something touching on the SIG node side as well. I per se I don't have any objections to the working group, and probably eventually it will, once we serve the initial goal of ensuring that we can safely run the serving workloads, the work will naturally graduate to all the appropriate SIGs to handle their own topics. Jack, you had your hand raised.
Yeah, thanks. I'll wait one more second just to see if anybody wants to respond to Clayton's earlier question, because this is different. Okay, cool. Hey, thanks, Sergey. I don't know if SIG Apps is the perfect place to ask this, but since I've got you, Sergey, I'll ask you. I've been thinking about, so traditionally, resource configuration, resource constraints inform obviously scheduling, but also the types of auto provisioning that you're describing that are going to be needed for these types of hardware workloads, because they're not always available and they're super expensive. And I was wondering if folks are thinking about the inversion of that, where we actually use something like SIG multi-cluster defines queue. So something like a queue of work that is secondary in the flow, and the primary trigger is actually getting the hardware. And so that informs, and rather than say the pod informing the new node informs the pod. Is that scenario under consideration? Is that already half baked? Does that make sense what I'm asking?
Do you mean to scale workloads opportunistically to fill the available hardware?
That's right. Yeah. But the hardware availability being the trigger rather than the pod saying, I need to be scheduled, go find me, here are my constraints, go find me a node. There may be accelerator constraints, sorry. But yeah, in this case, it's more like a continual actor that's opportunistically getting, say, configurable accelerator enabled nodes, and then some relationship between those nodes coming online. Maybe that actor is then sending messages to a queue somewhere that says, hey, I've got availability, I can schedule you. And then there's a TTL on the hardware. And so if no batch job needs that hardware for some TTL, then that accelerated hardware is released and someone else can reserve it.
Is this Slack capacity coming from elsewhere? Like, I just want to understand, where does since in the cloud you'd be paying for all that hardware already,
That's right.
unless it was reserved capacity or like a commitment, and then on premise it'd be mostly on, it's somebody's already paying for that. Is it just basically making sure that all the hardware that exists is in a cluster and that someone can use it?
Yeah, I mean, I think the North Star that I'm thinking of is a multi-cluster environment where every single cluster is opportunistically racing towards obtaining particular hardware acceleration that is available in that particular cluster, maybe in that particular region or whatever. Like maybe the multi-cluster fleet is distributed by region, and regional availability is going to have a significant part here. And then there's a common queue that can then talk to some multi-cluster thing that's like, oh, this cluster has this availability. Here I go, run this job here.
I would certainly queue to some of that with batch, but that's actually an interesting inversion. I haven't heard someone express it. I don't know if anybody else has.
Cool. Well, I think SIG Apps is probably on the lower rung of fidelity in terms of discussing this. So I'll get more organized with my thoughts and maybe bring it to the working group.
I'm curious because basically what you're describing is somewhat being touched by the batch and their topic that they have. It's called Q, but it's written with a K, where it tries and batches the works in groups, and upon availability of the devices or whatever the requirements to run your particular workload are, it can run them. It is primarily currently targeted at running jobs. Although last week on Thursday, we were discussing expansion of Q for other purpose workloads as well. And that will be the topic where the cluster has the capability, whether that's temporarily or some other actor is providing that from time to time. But that doesn't mean that we cannot serve that by default. And I think what is important is we want to make sure that both of those use cases are working. First, the one where we have a demand to run those applications, and then based on that demand, we can scale the clusters up. Whether you have the resources or not, that's a separate topic probably, and we can cover both. But also you can invert that and address the same topic by using the maybe not necessarily primitives that are available by default in Cube, but by the primitives that are available by the broader community, and make sure that both the default use case, what I would call, is what we've been trying to do, and the inverted case that you're proposing are achievable. Yeah.
Yeah, that makes sense. I mean, I think what I'm describing is going to be like a composition of a bunch of APIs. It's an end-to-end scenario. It's not like a single API scenario. But yeah, so long as people are defining APIs within this space, making sure that both scenarios that the API can fulfill both is super important.
Yeah, that's fair. Yeah, go ahead, Clayton. Sorry.
I was gonna. So there's two actual subvariants of this that I haven't heard anybody mention, but a serving workload that has no capacity on it or is no one using it is effectively wasting expensive capacity. I haven't seen anybody really discuss this, but there's certainly an interplay between batch inference and online inference, where if you have a set of batch inference queued, you might just want to go intersperse it with your serving workloads. And that adds another wrinkle to the demand supply, right? Like for cost reasons, if you can't use the capacity, you should give it up so that other people can use it. But batch and serving inference isn't that different. And at the limit, if you send more and more load to a model server, in theory, you'd be able to do things like, you can get batch efficiencies by detecting when you have a certain amount of workload and just shift into a batch mode. I haven't seen anybody discuss that one specifically. I do think that would be interesting. And then one of the things you're talking about too, Jack, and I've seen this come up in other discussions, I think I saw it in the SIG auto scaling notes actually, was the general challenge of you have capacity in all these regions. All that capacity has a cost. If you're already paying for it, or you're going to be paying for it, the ideal outcome would be that you can use it in multiple places. So like Q is looking at one side of the equation, but the other side of the equation, I think, is when you can't always satisfy the available demand you have with the capacity you have, and so you have to make decisions. Some serving capacity could very well participate in giving up capacity to batch. Like a lot of people tend to think of serving capacity as pretty fixed because they lack the tools to really be confident that disrupting it is not going to impact end customer outcomes. It could be that there's another intersection there where you have capacity that's running on serving that you haven't scavenged yet, because it comes with a trade-off today, right? If you stop an instance, Cube doesn't really know. There's really not a lot of high-level systems that are standard, but like every end large user has some system that says like scaling or running more workload or taking this instance out is going to impact my SLO. It's just hard to predict. If we could do better at like serving workloads are a little bit more predictable, that might be a starting point towards being able to scavenge capacity from serving workloads as well. So it's not really called out in the use cases, but it was something that I think is worth the working group discussing, as well as can we have more priorities within serving beyond kind of that very fixed Kubernetes static priority, but instead priorities based on demand or load or how much slack headroom the workload has. So that's also come up that I think is similar in concept to what you're describing, but expanding it beyond hardware capacity to slack capacity or headroom.
Yeah, that all makes sense. I think most of the primitives probably exist to implement that kind of multi-tenant serving plus batch. You can define priorities for one or the other. But yeah, I agree that people probably do tend to think, I mean, honestly, there's probably whole teams that do one or the other, and so they don't even talk to each other in practice.
Yeah, and you cannot dynamically fiddle with priority today, which makes sense, but you also can't, like most serving workloads, if you disrupted them, you really have no idea what the outcome would be unless you've tested it, and you do that per workload. So the other factor is there's nothing forcing people to think about that all the time and to build it into their automation. And if they did build it in their automation, if they did think about it all the time, because Kubernetes forced or encouraged them to, then suddenly, just like disrupting nodes was a big deal 10 years ago, and now disrupting nodes is still kind of a big deal. But most people don't worry about node death. They worry about fixing it afterwards or worrying about state. Maybe we can do the same thing for some of the serving so that you have more access to that. So dynamic priority is the closest word that I've a priority of importance.
Does the dynamic allocation cap address this? I would think it would.
No,
it doesn't.
Separate, completely separate problem. Like this is my serving workload is less important than other workloads. Yeah. But there are scenarios where I could scavenge that capacity for a period of time. So it's modulating your priority based on how much load you have. Like you might actually just want to keep the accelerators allocated, but repurpose them. There's some things you can get away with serving that you can't with others. So the whole separate topics. It was a great question because I haven't thought about the demand-driven side. And I think we do want to make sure that serving takes use cases from people who want to use their capacity efficiently, for sure.
Yeah, I mean, honestly, the main driver I'm thinking is not wanting to give up. If you have a reservation, just not wanting to give it up. And so giving folks like first-class interfaces where they can do that, where they can predefine a huge queue of workloads so that when they get capacity, they can burn through it, as opposed to the current model where they're not thinking about that because, infra is cheap. This is the sort of like 2015 assumption. And so you just give me a workload and it'll magically run, and I don't care about the infra. So now we do care for the next 10 years or so, at least.
Does anyone else have any questions, thoughts? Yeah, that's fair, Chuck.
And Chuck, I do want to make sure that working group doesn't overly rotate on cloud. I think there's a number of us who sometimes get a little cloud fixated because I think there's some, to finish Jack's point, or to carry on Jack's point, like before, hardware was something you racked and stacked and you tried to pack it efficiently in most cases, but you didn't worry about it too much. Now it's, you need even more hardware. You're going to have it in lots of places, and when you do get it, you want to hold on to it. So I think it's kind of maybe saying like cloud has a little bit of the scarcity mindset that bare metal and on-premise has always had. We don't want to get so excited about like provisioning stuff on demand that we don't think about the lessons that we have from like people who are dealing with scarcity day after day in on-premise environments, and like making the use cases, having solutions that work for both.
Okay, I'm not hearing any additional questions. I guess the next steps, Sergey, would be to figure out who the chairs are for the working group. I'll try to follow up with you later this week with potential names. Do you have anyone that you were thinking? I'll try to figure out someone from SIG Apps, whether that'll be myself or someone else will I'll make sure to reach out to you with a name this week.
Yeah, that would be great. We also want to make sure that there is a diversity of companies, and this is actually one of the requirements from steering committee. So yeah, if you can give us name, it would be great. Thank you. And I plan to send PR with working group proposal today, right after this meeting. I will put TBD in the chair name, but and I'll be waiting for to hear from you.
Yeah, it would be good to get a closure sometime this or next week, and so that the group could actually start meeting and actually put ideas together in 131 already. Cool.
Yeah, thank you very much.
Thank you very much. Does anyone else have any other topics or last comments, thoughts? Okay, hearing none. In that case, thank you very much for today, and see you next time. Bye all.